Hi everyone, and welcome to TaskGen Part 2. So what is TaskGen? TaskGen is basically the answer that I've created in order to do task-based processing that is more targeted, less conversation-like, and try to help you to get your task done by mapping to some available functions or mapping to other agents. And so this is called TaskGen. We talked about it previously back then about how to define agents, how to equip functions, and so on. And today will be part 2, where we will showcase some live demos of how this can work, as well as introduce some of the more advanced features of TaskGen. So without further ado, let me just introduce you, Brian. He basically has helped to contribute quite a lot of examples on the TaskGen GitHub repo, which is on this link here. And so today he'll be sharing some of his examples, and I'll also be sharing some example about a more recent project that I'm trying to do, basically a chatbot interface to TaskGen. So without further ado, Brian, please.
Okay, hey, thanks everyone for attending. Let me share my screen. Let me see if I can share it. Not sure. Oh, okay, I see the screen. Okay, can everybody see my screen?
Yes.
Okay, that's cool. How do I? Oh, never mind. I have to make it full screen. So I guess I'll just go through some examples. I only have 2 examples to share today. One is a RAG chatbot and a web browsing agent. So for the RAG chatbot, this is how I kind of designed it to work. You have a user and it goes to an agent, and you have functions like store name, greet user, and the more important one would be how to ingest a JSON a document, and then how do you access the relevant documents from the JSON data. Then you can ask questions to the agent, and basically you give you the answer that you're looking for. So we have it on the TaskGen repo. Again, if you go into TaskGen, you go to contrib, and basically you can find it under chatbot, right? So what I have here in my repo, basically I have data under documents .json. I made it quite long so that if you basically it proves as like it's actually working. And then I have a chatbot .ipa env. So basically how you would use it is you would have a .env in the TaskGen repo. All you have to do is to git clone it. So you have an OpenAI API key, and once you placed it in, then all you have to do is just install the requirements.txt here in your .benv. That's when you go to chatbot, and then you just the IPA BNB, and you pick the virtual environment. So I won't go and recreate that. I think everybody should be able to kind of do it themselves.
Actually, they just need to download the whole folder, right? Then just run the Python notebook. It should work, right?
Yes. Yeah. But they still have to. I mean, pip install the requirements.txt under this folder chatbot, right? Yeah. So I already placed everything in there. So then once you run it, then okay. And then so what happens is I have 4 functions: store name, greet user, ingest JSON, access relevant documents. So the first 2 is very simple. From the first 2 tutorials, you can kind of like read through how to use shared variables. So I won't really go through that. But more important
today
one,
we'll be talking about shared variables. This is the features also. Shared variables, memory, basically the 2 things we implemented here. We'll be going through it today. Yeah, because those are more advanced features that allow basically you to share information between functions. That's shared variables. And memory allows you to put in as much data as you need, and will extract only those needed for the task. So that's what these 2 functions are.
Thanks for explaining that. And then so what I have here is I have the function list to basically store the functions that I've defined earlier. And for this one, is a bit more complex, the ingest JSON data from the path. So basically what happens here is you do a JSON.loads from this document path. And what happens is JSON.loads converts it into a list of dictionaries. I'm not too sure how that works, but I just know that there's a library for this, so it's really cool. So, and you can basically play around with the options here. If you need it to be a bit more, you need it to change maybe a top K, change to 5, but basically I left it here just so you can play around with it. Basically what we're doing is we're storing documents.json into this documents under memory bank. And then when we create our agent, we must have documents. We must first initialize memory bank documents, and then I just put this back into store the functions back into memory into the agent memory, so you can then again change however you like it. So let me just put in my user, so everything should work. Yes, so I put in the user, and basically what happens here is everything loads as normal, so I can proceed. I store username and memory.
Oh, by the way, the function-based memory is actually automatically done, so you don't really need to do this externally. Like once you assign your functions, we will automatically populate this function memory that will rack over your functions based on the task.
Yes. Okay. So what happens here is I store the user's name in the memory, and then I just print out the agent output. And so what you can see here is okay, nice. I define store name, and then it says nice to meet you, Brian. So, and basically this is how, and you see I can see that it works. So I just run it again just to see whether it actually greets the user. And okay, so this is an issue because under the functions, I didn't have a input. So this is one of the bugs that that TaskGen has. So hopefully it'll be fixed. But if you want to ignore it, you can. If you don't want this to happen, you can just put a dummy variable like X, or then you just put a number, and then you don't actually use the number. But you can see it, as you can see, it works. So then they basically retrieve my value from the shared variables. So it says, "Oh, Brian, can I assist you today?" So the more important bit is to actually have RAG working, right? So everyone wants to know how the RAG is able to get things done. So see what I have here is basically what I have here is I declare the path to the documents.json, and then I say, hey, ingest the JSON data from path, and then I store it into memory. So and then after it stores into memory, once this is done, then I ask the user, which is me, like, okay, what do I want? What relevant? What things do I want to know from this document.json? So I guess something interesting I can pick, maybe that's so hard to read. Work from home policy created at no, I want to see effective March 2020 first. Yeah, so I guess when I'll ask like when is the work from home policy effective March 2020? Okay. Oh no, sorry. I think this one is a better example. Starting May 2022, implement. So when will the company implement a 2-day in office requirement per week? Say when will company implementing? When I go back to, let's see.
Nice. It's like a QA chatbot for this.
Yeah. So I mean the pattern is here. So if you have a use case for this, you can just, oh, why not?
What's happening? So this is the issue live demos.
Oh man, it worked yesterday when I was playing around with it.
Can I see the error? Function object is not subscriptable.
Oh no, this is so sad.
Yeah, I'm not sure why.
Oh, I know why. Because I deleted I used a different version for web browser implementation, and then that was the last one I was testing. Yeah, I don't think I want to re-download the BNB.
No worries. Yeah. Anyway,
Yeah.
for this one, right? I think the main thing to take note is if your functions have a very explicit input parameter that is related to the user query, TaskGen can do the auto function calling mapping. So over here, I think the error here might be the versioning rather
Yeah,
than
it's a versioning.
yeah. So just now you mentioned about the no input parameter to the function raising an error. So that was an error indeed in one of the earlier versions, but with the latest versions, I fixed it already. So you can try again.
Yeah. So I guess everybody can try it in their free time. I mean, this one definitely works. Because I've done a lot of like testing on the recent web browser implementation. So this VNV is actually for this web browser. So sorry if disappointed if I disappointed
No worries, no
anyone.
worries. So
Yeah.
for people who use TaskGen, just take note that the more you use it, the better it gets. So if you feedback this kind of errors to me, or like whoever's going to develop this in the future, we will try to fix it. So it will make it more and more robust for the use cases.
Yes. Okay. So now that I've got the right chatbot out of the way, I like to like show this web browser agent. So basically, the user will just ask the planning agent what to do, and basically, it will be able to tell the manager agent, writer agent, and it's supposed to be web agent what to do. Yeah. So yes, I'll go through the web browser. So web browser isn't really finished yet because there's some issues with passing shared variables that are not that I can't really remember what the error was, but if you have a string that's too complex, basically you can't really pass things. But the concept is here. So basically what happens is it here? Yes. So to use this, basically what I do is you would cd into this web browser implementation, and then you run these commands. You run like a Python -m, and you create your VNV. Then you pip install requirements.txt from these requirements, and then so what happened here is I source activated this VNV, and now I'll try to run it. So I have two scripts just to kind of show you how you can have TaskGen do multiple functions for you. So start off with this combine.py. So what I have here is many different functions. I have defined type type tags, click the screen, take a screenshot, uh, and then I have like different functions for creating different agents, like creating a writer agent, creating a manager agent, and then create a web agent. So
It,
they
it's
have
quite
all
cool, you know. This one feels like app agent.
yeah.
Like
So you have
browse the web for
multiple
you.
you have multiple agents that can do things for you, and so and then you also have a base agent. So the base agent is, I feel that is the most important part of TaskGen, right? You really want the agent managing the other agents for you to do things. So basically what happens in the script is you create a base agent, then you basically have this task, like click the screen 1200, then type the text like hello world, and then take the screenshot. So basically you don't really know what's going on behind the scenes, but as long as you tell it, and then you will be able to coordinate like the manager agent to take the screenshot, then the writer agent to click the screen and then type the text. So then now let's try that, see if it works. Oh yeah, and then you basically will have to assign the agents under base agent. So this one orchestrates everything. So let's try that. Python.
This is really cool. Yeah, basically this is an example of the hierarchical agents. Like you assign agents as a function within an agent.
I click here.
Yeah.
Oh, it should click. It's kind of strange.
which version of TaskGen are you using for this?
I'm using 1.2. Okay, and then it just says hello world. Okay, well, at least that one worked. Then it should take a screenshot. Let's see. Okay, it says captured the screen display, so I'll go and see the screenshot.
Oh, that's really cool. Okay, so I myself need to see like why your first one didn't work. So the first one just went to the agent and the agent did nothing, right? That's the
Yeah.
okay. Yep. Cool.
So now it's 26 March. Wait, how do I see? I forgot the.
Wow.
Yeah, but basically you can put the screenshot in here. Oh, you didn't put the screenshot. Let me try. But anyways, the cool thing about this is basically I'm able to have different functions. The cool thing about doing it this way is that I can put many different functions in under utils, and I have the env loader, and I can get the agents to kind of use this even though they're from a different folder. So it really modularizes things. If you compare it to things like app agent, when I read the repo, I can't really tell like where are you importing things from, why does your agent do. So it's a lot more readable in a sense. Yeah. And so let me try this web agent. And now let me try the web agent underscore. So it should be able to.
I think there's a lot of work they have done. Like coding this out is something that I think requires a lot of effort. Yeah. So
Yeah,
wow,
I mean
great work.
that's why I feel I need to contribute more, because like then everybody has more patterns we can copy from each other, then it makes everything easier. Yeah, so the web agent works. I only made it like to go to a domain. So how this works is, and how the web agent works is, it's basically I have different functions, like create new instance of Chrome driver, navigate to a web page, that I put in scripts under actions.py. So I use Selenium. The problem with using Selenium is it's with shared variables. There's a caveat to like this deep copy issue. So I think there's like other frameworks that you can use. Like there's a new one called Helium. So maybe I don't have to use a driver to put into shared variables. So it should be able to run. Yeah. And basically what I did is just ask it to, hey, create one new instance of Chrome driver, then navigate to www.example.com webpage. So you can really see like how if you bring everything together, you can really start to have a really robust agent. Really, yeah, I can do many different tasks. So these are the two examples that I'm intending to contribute to put under TaskGen. So when it's really complete, then maybe I'll do another demonstration over again. And so I want to share like a bonus, because everybody wants to know like what is the real life use case of making a web application with TaskGen, right? So I'm currently working on a hobby bot, like basically like to automate parts of AWS that I don't like to do. You know, like AWS has a lot of commands, and I don't like to memorize. Like, oh, I want to create this S3 bucket, so on and so forth, right? So that's so let me share with you how I kind of did that. So this like last example. So I have this a web full stack kind of thing going on. So it's using React and Django. So I guess I can start this. How do I start this? I have to do manage.py. Let me go read me. I totally forgot. Okay. npm run dev. Oh, why is it not there? That's strange. Oh, I know why. B underscore react. npm run dev. And then center Python source PNP, then activate, and Python .py on server. Okay, and that should work. Yep. So I go down to here. Nope. Yes. So I created this like AWS bot that can kind of do things for me. So what I've done is I try to make a chatbot that can run AWS scripts for me, and I place it under Django. And if anybody knows Django, actually I won't explain Django too much. But basically, what I do is I make this Django into an API server kind of. Then you can just ask it questions. So what I've done is basically I've given it the functions to like, okay, greet user as usual, and then you can create S3 buckets. I mean, list the S3 buckets. So let me try and see if I remember what I want to ask it. Okay, maybe I ask this S3 buckets in AWS account. Oh.
That is actually very cool. Like, so you're already implementing like the chatbot interface that like some people have asked me. So later I'll also be demoing like how a potential integration of TaskGen with a chatbot interface might look like. But this is really cool. By the way, all the examples that Brian are showing are all entirely his work. All right, I did not guide him or help him in any way. So it's amazing how in such a short period of time he could do all this already.
Is it loading? Let's see. Python. Oh, it's running. Okay. Why is it not showing my access the best? Oh, okay. So basically, you can give me my output. At least my buckets. I'm not really too sure why it's not listing my buckets in the.
So it's actually the TaskGen part is complete. It's just not reflecting on the server, is it?
Yeah, it's not. Oh, okay. Yeah, nice. Okay, so basically, it showed me like what are the buckets that are in my AWS account, and I can even ask it to create an S3 bucket for me. But I kind of forgot how to ask it to do that. But anyways, so there's still the thing about making it into this chatbot interface. I feel that at the end of the day, you still need to know what functions that your bot does, and then you still have to ask it in a correct manner so that you can it's more reproducible, right? So but then you can see I basically I can list out the buckets in my AWS account. So I mean, if you add everything up in all the examples that I've shown before, I can really see TaskGen creating this fully fleshed out chatbot that can start to do your daily drivers for you and automate many things. So that's really that's really cool.
Oh, that's very cool. Yeah, thanks so much, Brian, for doing all this.
Yeah.
So as you can see from his examples just now, he managed to integrate like question answer bot, some AWS tool assistant, a web browsing agent. Actually, it's really cool because I myself haven't done all those. I basically just did a framework to do pattern matching between the user intent to the functions. It's very interesting to see how this can be taken to this level. Of course, as you also saw in the demo, there's still some bugs that need to be ironed out. Those bugs could be the way the function is implemented, that it did not shared variables did not store properly, which is actually not really shared variables. Spot is more of a case about how to store reliably in a Python variable, so that those issues can be ironed out. And so the more you all try out, and if you feedback more errors to me, we'll make this more robust. You have anything to conclude before I move on to my sharing?
Yeah, so I guess actually you already kind of shared like the conclusion, like we need more examples to get things production ready, and we can improve our robustness. Then we can have more patterns for everybody to copy. So I don't have to do so much hard work. Right? Then developer tools and resources, like eventually we definitely do want this to be like more advanced. Like if I can have Postgres SQL as my database instead of JSON as a database, SQLite, all that kind of stuff, that would be very interesting. And also one thing I've noted is like secret variable, like handling secrets. Like when I use the AWS, as you can see my AWS. I will delete this, so don't. Yeah, so don't worry. Yeah, I'll have you can see AWS secret keys and all that here. So I mean, that is a bit troubling if you wanna put things to if you want to start implementing TaskGen into production today. So I hope
have you tried
everybody.
putting it in some external database and then just retrieving from there?
Yeah, I actually put it in I actually didn't do that. I put it in my .env.
Yeah, so if you want this to be private,
Yeah.
what you can do is you could just access at runtime inside the function itself. Or what you can also do is you just put in shared variables, then you just don't show the shared variables to the user, which is entirely possible because shared variables is, later I'll talk more about it. Shared variables is only to the function and the agent will know about it, but it's not in the history of the subtask completed. So no one will know about it. And if the user asks the chatbot something, the agent itself also cannot just take the shared variables and reference like that. So it's kind of private, but the most secure way is you just put it directly in the function call. So, when the agent is equipped with functions, in your function call itself, you retrieve the API key. And this will be totally transparent to the user.
Okay. So I just have, instead of putting in like here, I will.
Yeah, you put directly in the function.
Okay, put in direction. Oh, okay. I got it.
We can discuss more. Actually, like in Symbian, we use like TaskGen, and actually there's some production stuff that some tips and tricks, and we can talk more about that. Yeah, I just didn't expect that your use case would be so production already. Yeah, we can definitely chat more.
Okay.
Okay, Derek, you raised your hand. Anything you want to ask?
Yeah, I did. Just real quick for Brian, while you were working your production use case, did you do any experimentation with kind of like agent depth, like defining functions or agents as functions, and then like kind of going down that pipeline of agents? Like, I guess what I'm trying to say is like agent, and then you define the agents for that agent, and then like going down that pipeline of like functions as agents or agents as functions. Like, did you like run into anything like that, or did you just keep it at like just like the first layer of agents?
No, I just did the first layer of agents, and I think I definitely did come across the idea of like if you use like agents to create functions. I think that's what you're trying to get at, right? Like you don't have to tell it. You don't. If we have to write all the functions ourselves, it kind of becomes like a more advanced form of RPA, right?
Well, no, yeah, I had another idea about that, but no, I was just like saying like in general, like experimenting with like agent depth on like how deep it can go. But you just kept it at like the first layer of like agents and predefining them.
I think what Derek is asking is whether how deep can the inception be, like agents calling other agents, calling other agents, calling. Yeah, so the functions can all be predefined. It's just like how deep can the agent stack go? Like agent A call agent B, then agent B call agent C, and eventually you map to some functions.
Yeah, the agentception is what I'm trying to get at.
Right. So there's some practical guide for this. Because whenever you call an agent, we have to call the planner to do planning. And what this means is that there's latency involved. So the deeper you go, it will help with filtering, because like if you categorize your top agents by broad intent and the bottom agents by more specific intents, you can sort of do filtering by calling multiple levels of agents. The cost is latency. So for me, the advice that I normally give people when they want to do something like that is that if your bottom level agents just only do one thing, all right, then maybe what you can do is you can just put everything in a function. So like the top level agent calls a function. Inside these functions, maybe you run a certain fixed process, all right? And then you just return the output. So you don't have to keep calling agents after agents. If you already know what you want in the sub agent here, you can just execute that pipeline and just return the result. Yeah, that will help to save a lot of latency.
Yeah, I figured it was a latency thing. I was just curious about like numbers, if there's like any data or experimentation.
Yeah, I
That
would
was just
recommend
my
just
curiosity.
one level of agent, because like if you do 2 level, maybe the user might need to wait 10 seconds per query. Yeah, you do 1 level, the user wait 5 seconds. As you saw in the AWS example, if
Yeah,
you
it's very long.
if you do it at the chatbot level, the latency might be long. And actually, we also realized that if you actually need to call like an external Python package, if you use like Django backend or something, I don't know what's wrong with this backends, but it took very long to do the calling. So one solution that I have for this is that you run TaskGen locally. Like you take the entire TaskGen folder, you put it inside your environment, so you don't have to call TaskGen remotely to like the PI package. You can just run it locally, it would be much faster.
Okay, that's smart. Yeah, I like that.
Yeah. Or what you can also do is if you don't have to use the agents, you try to use the StrictJSON functions as much as possible, because the latency for StrictJSON is very low compared to the agent call. Because when you do the agent call, you need to evaluate, you need to look at the past history, you need to match to a function. Actually, if you already have the function in mind, you can just run the function directly. So these are just methods to save latency for production use cases.
Okay, that's good. Appreciate it. I just wanted to ask.
Yeah, no, I think it's important to think about how this can go into production. I mean, when I first came out with the framework, it was more to do matching to the like what the user want directly into the space of the functions. But of course, once we do it to production, you need to optimize a lot of pipelines. So that's the next part. All right, Kyron, you asked something. You said, would the Brian's first example of injecting JSON into memory, will it work with thousands of JSON files? Is it?
Yes. I'm glad you mentioned about production. So I have like a personal knowledge management system where it's pretty typical, in a corporate environment, where people have personal knowledge management systems like, Obsidian, right? And in there are thousands of markup files, and those files can be transferred to JSON format. And one of the projects that I'm working on is really to do exactly what Brian did in his first example. So in a production environment, would it be able to inject like a few thousand JSON files into memory and then search against it and ask questions?
Yeah, so I let Brian answer what he thinks about it first before I give my answer.
Yeah, so actually, in such a case, I would think that by the time you want to use it for such large amount of documents, that hopefully you will have integrations with things like Postgres, something like that. So you throw your markdown in those databases, right? I mean, and then you can do your vector search from there instead of you throw everything into the memory. So
Okay, so yeah, to answer this question also, to follow up, the current memory implementation in TaskGen, it goes through every single database item line by line to do like cosine similarity mapping. So if you go to millions of entries, the current implementation in TaskGen is not meant for that. Okay, that is just meant to do like maybe if you have 10 or 100 variables, you want to match the database. Like basically you have some things that you want to imbue some additional context to the prompt. Later I'll explain more. You can do that in the current memory bank. But if you scale up to millions, my recommendation is just use like Pinecone or some vector database, because they have algorithms there that are optimized to do that. And you can just integrate this as a function in TaskGen to retrieve data. So this can even form a part of the pipeline. So even without TaskGen, you can already retrieve data as the first part of the user query. So you always do this retrieval step. Then you put that into maybe the some additional context in TaskGen. So today I'll be covering the additional context part. It will solve a lot of the issues that Brian is facing. So Brian doesn't know about additional context yet. It just came out last week. So this will solve a lot of this kind of production issues that, hey, how come my variables cannot be, seen by the agent, is not focused on. So additional context will give that focus. And so if you could do a fixed pipeline to do retrieval, put the important information in additional context, the agent will base on that to make the decisions. So I would say for production use case, the memory bank part, won't scale for millions because I don't want to recreate a vector database. I think you can just use the vector database for those use cases. What you need to do is just take whatever you have from the vector database and put it inside the TaskGen prompt through additional context. Or you can put it as a, you can put it as the memory also in TaskGen. I mean, if you already have a way to take the data. So hope that answers the question. Yeah, you probably should use a vector database if you want to scale up.
Okay, sure. Okay, great. Thank you.
Okay, so now I go to my sharing. So, okay, so it's a little late, but let me just share this one here. Can you all see the screen?
Yes.
Okay, so recently I was asked, like, can TaskGen do a chatbot? Like, can the user do some task scheduling or, purchase some items and so on. So I went to try it out and I realized something, all right? I realized that if I were to do an agent, so the most straightforward use case is to do an agent and then assign the purchase function. So like this is the search function. So I search for the items. This is to buy the items. Okay. And then if let's say I assign another function called reply the user as a function, like the LLM. So this is an interesting LLM based property that I know is that the LLM would just choose the LLM to do everything. Right. So if let's say I have a reply user with LLM function, okay, in the current context, we have a reply user in TaskGen, but the reply user is not chatbot focused. It's very, very concise. The user won't like this kind of response. So we have to do another function to reply whatever the agent has done to the user. So I realized if I put the LLM function as one of the equipped functions to the agent might hallucinate and use the LLM function to do the buying and do the searching. So my solution for that, okay, I also asked some people who use AutoGen. They also agreed that this hallucination is a problem. And my solution for that is to decouple the response to the user and the actions to be done. So you can see in this, let me just run through. This is like a curated list of what the shop has, the name, the ID, and the costs. Okay, so we put this in memory and we retrieve by the large language model. We can also retrieve by ranker here, which means like concise similarity. But for this example, we retrieve by large language model. Okay, this is a shop assistant, and this is the action arm of the shop assistant. So basically, it will just do the buying of the items. If the user search the item, if user want to search, and buy the item if user want to buy. And I condition this buying on this thing called item search. So this is the additional context part. What the user has already searched for will go for into item search, which means that we won't be buying things that are hallucinated. We will always be, or at least with a high chance, we'll buy things in this item search. We can also augment with a rule-based check to do this because LLMs are not great at rule-based checking. So this is my solution to a lot of hallucination problems and a lot of problems associated with, the LLM might do things and then imagine that it has already done, which is a huge problem in AutoGen also. We need to condition on some ground truth. And this ground truth will all be in additional context. So today I'll be talking more about that. So this is the get related items part. So we have a shared variables which we can take from the memory, like a shared memory between the agent and the functions. So we can take this item memory, which is this thing here, and we can just retrieve stuff that are related to the agent's instruction, the user instruction. And basically we can store whatever that has been searched in item search so that we can use that for buying later. So this is a function, returns 3 items, okay, and then we have a list of items. So you can see I want something sweet, they match to pizza, coconut, orange juice, right? Yeah, do something else like I want a car, okay, then it will match to car, bicycle, skateboard. So you can see it's semantic matching, all right? So this is how this is done. Buy item is basically you buy the item by the item ID. Okay, why did I use item ID? Okay, it's because large language models hallucinate a lot. If I were to put in the item name and the item cost, there's a non-zero chance that the large language model will hallucinate the item name and the cost. So by putting the item ID, okay, we can retrieve from the actual item database, okay, this item ID, and this will be the ground truth and this won't go wrong, right? So I think for stuff that requires very, very non-hallucination based stuff, it's best to go through a vector database to retrieve the item from it rather than using the large language model to generate, okay, because there's issues if generated stuff is hallucinated. Okay, so this is a way to bypass this. So actually, when you use TaskGen for this, do bear in mind that the way you encode your functions matter a lot in terms of how the agent selects the functions, because, you know, just like any human, if you tell me my tool, like I describe this handphone, I describe as a way to call people, then I know how I'll use it for calling. But if you just say this is a handphone, you know, sometimes the large language model may not know how to use this, right? So a lot of times the way we condition the TaskGen to choose the function is based on the function description, which is like over here, purchase item via item ID. And it's also based on your input variables. So your input variables are very important, because based on these input variables, if it already matches to something you have seen before, like item ID, then it knows how to use this function, or it knows when to call this function. When item ID is there, then you can call the function. So there are ways to condition the large language model or TaskGen to choose the right function based on what is present. And you can do that by the function description as well as the function inputs. So I'm just emphasizing this point because real world use cases, if you want reliability, I think this is probably the way to go. All right, now we have additional context. So I'm jumping a bit ahead of the gun here because I'm having an entire session to talk about this by showing the example first to just get you excited. So additional context, what this is done is that instead of the usual prompt, okay, we also have an additional prompt that gives important variables that the agent will need for decision making. So in this case of a shop assistant bot, we need to give it stuff like, oh, how much money is left? What are the items the user has searched for? What are the items user has purchased? And basically, what is the conversation between the chatbot and the user? Because, you know, unlike a traditional task-based thing where you just do the task and you list out the list of subtasks, for user conversation, you kind of want to know what the user has talked about so that you can infer what task the user has. Okay, this is an even more difficult problem than just purely doing the task, because sometimes the user does not say the task explicitly. Like I talk to you, sometimes I say, hey, I like the ice cream, but I never mention in that sentence buy. It also traditional like matching to keywords will fail. So how do you get the task out? Okay, you need to have this past conversation. You need to prompt the large language model in a smart way to extract the task. I mean, you can see that the prompt for the action here is like this, like end task if it's not relevant to purchasing of items, search for relevant items if user want to search, purchase if user has selected a particular item. The way this prompt is structured is so that, you know, depending on what the conversation flow is, we will extract out the action needed. Okay, so we move on to persona. So this persona is like similar to if you know symbolic AI, I think Tyrion is familiar. Like symbolic AI has a persona that you can test, like say this is a person that can do in this style. So I thought that was a pretty cool idea. So I did something similar. So like you can say that like, oh, the chatbot assistant is the style of Sherlock Holmes, all right? So we start with the conversation with nothing. We start with the AI assistant as the starting message. Okay, and then what we'll do is based on the user input, we'll key in the user input to the conversation. Okay, we only store maybe the past 10 conversation history so that we don't overload the context buffer. And this is a cool thing, okay, because we have this additional context here. We can actually reset the subtask completed for each agent at every time step, because the important information that the agent really needs to know is not really in subtask completed anymore. It's basically in additional context. So previously, if you use TaskGen, if you use it for too long, you realize that because the subtask completed, there's a lot of subtasks that have been completed. Sometimes it might affect running of new tasks, because the old tasks might make the large language model planning agent think that, hey, I already finished the task because my subtask completed has already been done. So I think in my later updates, I'm actually intending to, like every time the user every time we run TaskGen for something, I'm actually thinking of just resetting the subtask completed anyway, because if we already have this additional context and people use this by default, you know, the subtask completed, we can reset it to make a clean slate. It helps with better planning also, I realize. So basically all the important information, you go into additional context that will carry over between tasks. Then you don't have to store what subtasks have been done. Like you don't have to say, oh, I went to this web page, I click on this button. You don't have to do that, because you can put that in additional context. So it makes the whole interface neater. I also realized through repeated experimentation, this is a more reliable way to get the agent to do tasks. So Brian, I think you can also use this for whatever use cases you shared just now. It should work better. All right. So right now, for this interface to reply the user, as I mentioned earlier, the reason why I did not put this as a function directly to the agent is because the agent has a high chance that it will just use this function to do the buying and do the searching, which is not what we want, because LLMs are great at everything. They're also great at hallucinating. So we want to decouple the action arm from the reply arm. Okay, something that I don't think has been done in other frameworks, as to my best of my knowledge. But I think this is very important, because if we put the reply arm as part of the action space, it might be chosen for a lot of things. That includes like hallucinating the actions. Okay, so if we put this reply arm separate from the action arm, it's like, I don't know in your brain whether your explanation branch is separate from your actions, because like people have done experiments before, like the right side of the eye, they put the instruction, left side, they don't. And the person, like maybe the instruction is stand up, then the person stood up. But because the explanation side, I believe is linked to the right eye. Sorry. So they put the instruction on the left eye, the right eye linked to the left hemisphere, doesn't know why the person stood up. Like, I don't know. I stood up because I saw something, but because that is not linked to the explanation part of the brain, the person doesn't know. So the person might hallucinate something and say that, hey, I stood up because I was trying to stretch. So there's this experiment really done in humans, and it's been shown that the way we explain our actions has actually very little to do with why we do that. So this is very, very interesting. It's like we try to back reason things that are already done. Okay, if you want to search more, you can search for like the left or right hemisphere, the link between the reasoning branch of our brains as well. So I think this is something quite cool in humans. Like, why is this done for us? And through doing TaskGen, I realized that maybe the reason is because we don't want to hallucinate everything as an action. Yeah, so maybe we back reason so that our actions are really grounded in physical reality, like actions of moving hands rather than action of just hallucinating. Okay, so with that in mind, this is why the reply to the user is a separate part. And yeah, so we basically reply. Well, let's take a look at how this is done. So let's say, we ask like, I'm hungry, what do you have? So you can type free flow stuff, and then like Sherlock Holmes will answer you like, user mentioned being hungry, and then we can map to pizza, orange juice, coconut. So you can say pizza, orange juice, coconut. Do you have any preference? Do you want to eat? No, I'm just going to go with pizza, all right? Yeah. Get me the pizza. You can just say, get me the pizza. You don't even need to say like, so over here we have, okay, so over here, we have, okay, so it has called the search thing. Okay, so okay, again, this is a thing about prompting, all right? Sometimes you may not get what you want. So you can see that over here, we actually supposed to buy the pizza, okay, but they just called the search thing for pizza. So I need to refine the prompt. But let's say we want to do something like, let's say I want to, I would like something to travel on, right? So they can search for something, and then like, so bicycle, okay, let's get the bicycle. So if this is done right, we will go and do the purchasing of this bicycle. Okay, so again, you can see that here they say they did the purchasing for me. All right, let's retry this. Okay, so I have to refine the prompt for the action space. So this is not the agent space part, this is the prompt for this action space. Okay, because it's currently not buying the item. So let me just try again. Okay, get me a pizza. So you can see that we have searched for the pizza. Okay, yes, buy it. Okay, so let's hope that the purchase agent is called. So you see, buy item and parameters is called. So okay, yes, let's so I have a confirmation message for buying pizza inside the buy pizza itself, because like, if you want to do this for production use case, you cannot just like call a function that uses people's money without the user approval, right? So the user approval is in the function. So just take note. Yeah, so there's a user approval in the function here. So let's say yes, I want to go ahead. All right. So I purchased a pizza. This is my remaining money. And let's say I'd like to learn machine learning. So the user can, it's a very free flow chatbot, and then like we can see that, oh, these are the following items. You can even say like, you know what? Don't you have any books by Yan LeCun or something? Okay, I did not program this, but I'm just giving you an example of like how the free flow chat could be. So in the end, they did not have anything. So So this is like how this is done. Any questions on this? Because I think this is an example of like how like a real world chatbot could be built just by interfacing the action space with the agents in TaskGen. Okay, and the reply would just be based on what actions have been done so far. You just reply the user something. All clear about this example? Okay, so let me just type done. So of course you saw that there was a hiccup just now, like it did not buy the item, and this means that you kind of need to prompt better here. And not just that. Okay, later when I introduce you the idea of memory, actually you can also do memory-based queuing. So basically, when the user says, I like to get this, you can map, I like to get this to the function by item. So you can do that as memory. So you can sort of guide the large language model when to call certain functions and make it more performant as well. Okay, so the other example, I'm not going to run this, but I'm just going to show this to you. Is like you can also use this to like navigate a maze grid. So in like my paper, Learning Fast and Slow, I did a 2D environment where, you get a certain start position and you want to reach the end position of some obstacles. So, we could generate the grid, move, okay, and then basically the additional context will be where the agent is, exit position, what are the valid moves and obstacle position and so on. So this helps the agent to plan a bit. So you can see like this, the starting grid, S is the start, E is the end. And given this, is able to call like down, right, and so on, navigate properly. Okay, then also I realized that, if the subtask completed here, it's just like move down or move right. Sometimes just moving down, move down, move down. You might move down 5 times in this kind of situation. It confuses the agent. All right, a list of very similar actions. You can try on ChatGPT. You put move down 7 times, move right 3 times. You ask what has been done. Sometimes it doesn't give you like I moved down 7 times and move right 3 times. Sometimes it doesn't do that. So that's why in this first version, I basically asked it to list what start state and what end state in order to mitigate this issue. But this is not foolproof, because sometimes you might go from this state to another state again, and this will confuse the agent again. So what I recommend doing, if let's say your use case has many similar actions, okay, is to just reset the subtask history every step. Okay, what you do is like this. Okay, you have the additional context here, right? So you can basically just reset your agent every time step and basically just do a new task every step. And your new task will update your new start position and end position. In fact, even if you don't do start and end position, you just say navigate to end position is good enough. Why? Because in your additional context, we already have the start and end. So the agent can use that to make decisions. So with this, I think this actually improves TaskGen's reliability like 3 or 4 times compared to the native version without this additional context. So I've tried this, and I think this will solve a lot of problems that Brian was showcasing in the beginning. And yeah, hopefully this can solve it. If not, we can do something else as well. Okay, before I move on to the presentation proper, anything you want to ask me about what I just showcased? Or you understood? Like, all these are in tutorial 5, by the way. You can take a look in the TaskGen repo. Okay. Okay, a show of hands, are you all able to see the slides right now? It's currently at the TaskGen showcase slide. Okay, so now we have gone through quite a technical demo of like the TaskGen's capabilities and so on. Of course, you can see live demo is not perfect yet. Okay, we are still improving on it. But in most cases, the idea of matching from the user task to the functions, I think this is a very, very core idea of TaskGen. So part 1 is basically a few weeks ago. The main things that we covered were like how to split your task into subtasks. I think this is a main part of, this is a main part of problem solving, how to split your task into subtasks. Okay, how to assign your functions, be it LLM-based functions, which is using the large language model to generate an output, or you interface with an external function like with the AWS database, maybe. And you can call agents within agents as well. So these are the stuff we went through in part 1. So today we'll be focusing more on the advanced features. And I think these are the features that will make TaskGen more production ready. So we have shared variables, which are what Brian has showcased just now also, to put data, like for example, the data from the JSON, that you extract from your documents, you can put in shared variables so that you see, if let's say you have a document thousands of words long, you don't want to put that in the agent history or agent planning context, because imagine if you download 100 documents, that will easily overwhelm like the 8,000 token limit in ChatGPT or like the 32,000 token limit. Okay, so we don't want to put lengthy stuff in the context of the agent, so we can put them in shared variables. You can even store stuff like text, video, and so on as a path link, so that if let's say you store, say for example, video, you can do video processing with that link later on with the path, the file path. All right. So there's other things like retrieval augmented generation over function space. This is done automatically as you add in functions to TaskGen, and you perform a certain task. We will do like the top K selection of functions by semantic similarity for you automatically. You can also define it yourself if you want to. Okay, memory to provide additional task-based prompts. I like this so much. Okay, I think this is the key thing of TaskGen. If you don't use this, okay, it's missing a key feature. Because why? A single prompt can only do so much. All right, it only does a very specific instruction. But if you do memory-based things, you can augment the prompt with certain key things that you have in memory. It will make your prompt very robust, like based on the certain situation you're facing. Like for example, if you want to search the web, then you can just search in your memory whether you have any web-based prompts, and then you can put that to the agent. So the agent, it's like you have modules, right? This is modules for your context, your modules for your prompt. Like normally people think of prompt as a static prompt, right? To the large language model. But actually the best performing prompt is actually a task-based prompt. Based on your task, you augment certain sections of the prompt. All right, I will go through some diagrams for that. And if you have already some idea of what you want to do, be it a web agent, shop assistant, and so on, you can put this additional context, okay, to configure your own prompts. And basically what this does is you can put in very, very key information inside your additional context. And then this context will be used for the agent for planning. You can reset your subtask completed every task, which makes the agent work much better. All right. So this again is the design philosophies for TaskGen. So we want to make the context instruction as concise as possible for minimal token use, so that we have more performance. We are able to perform better, and we also save cost and latency. We want hierarchical agent calling because we don't want an infinite loop like the AutoGPT or Baby AGI. You can keep doing the subtask again and again. All right. The agents share the same structure as meta agents so that we can do modular recursive implementation. And the key thing about this agent level abstraction is that at each layer, each agent will have different forms of abstraction that are suited for the agent itself, which means more targeted behavior, better reliability. Right? And the planner agent basically will create a list of steps to fulfill the task. At every step, we'll check the plan, and each step will be mapped to one function. So it ensures a constraining of your output space into only what you equip the agent with. That's why the way you describe the functions and the function inputs are very important for the performance of the system. Because if you don't give it the right functions, it will not do the task for you. Or you give it function inputs that are too vague, no, you won't be able to map better. So this is quite important. So function-based planning, this is the key thing for TaskGen. It plans only based on the functions you equip it with, right? And of course, LLMs don't really know how to check whether it's done properly. So we have a rule-based check to exit once we fulfill all parts of the initial plan. So this is the recap for TaskGen. So again, we have a task here. It goes into meta agent. Meta agent was split into like a list of steps. Each step will be done by a function call and returns back here again. Sometimes a step will be very complicated. You go to the inner agent and then return back to the agent again. And eventually, once this is done, we'll end the task. And one important thing to note is that the agent's context, like what the agent is trying to do, what task the agent is trying to do, what are the subtasks already completed so far, all this would be passed down to the inner agent so that the inner agent will have some idea of what's going on in the main agent. So this ensures continuity of context. So once the agent or the function has finished, Okay, we will also store this in like subtask completed, or if it's too lengthy, we'll store in shared variables. So that's at least the workflow so far. Questions on this recap before I move on to today's new features? Or if it's good, maybe just give me a thumbs up or something, so I know that you are still following. Okay, that's great. So I hope you are excited about this brand new features, because trust me, it really made TaskGen work like 3 or 4 times better and more reliable for me after I implemented those. So I'm very excited to introduce you shared variables. Okay, so shared variables are like this, all right? Let's say you want to do a very complicated task. A task involves many steps, all right? Like find 5 words rhyming with pool. So this is tutorial 1, all right? So compose a 4-sentence poem using this. So you can see that based on what subtask has been completed earlier, this will be able to like act as a context to the function's next action step. So let's say if I need to put these 5 words into some function, I can put them as a function parameter because I have that as my context before that. I can use whatever steps have been done before to do the next task. That has worked quite well for very simple tasks. But I realized that as you want to scale up for production, you can't do this for everything, because not everything can be expressed that well in terms of words. And also sometimes you might have millions of words and you don't want that to appear in your subtask completed. Imagine your agent has just 1 million words for one document and you ask it to summarize it. That won't work, okay? You'll run out of context length. So instead, what we should do is we should store it outside of the context for the agent. We should say something to the extent like, hey, I've done something. So your shared variables over here, what your agent needs to know is agent just needs to know like task completed or subtask completed, and like output stop where, or provide summary, like for example, button click. Yeah. So sometimes when you're doing an agent as an OS, like operating system, you don't really need the agent to know like the full details. Okay, this is the XML of this page, these are the colors of this page, all these kind of things are only relevant for the agent that is trying to click the button or the agent trying to design the web page. But the main agent, doesn't need to know all these details. Okay, let me give you an example. Like you are the boss, and then you ask your workers to help you to maybe do okay, let's do a task, like for example, arrange flowers in a flower pot. Okay, so you have this schema of how you want to arrange the flowers in the flower pot. You ask your man to do it, and the man sometimes can say, hey, this flower is like 5 cm lesser than the other one, and it doesn't really fit in this schema and so on. So to the main agent, actually what you need to tell the main agent is not like, oh, this flower is 5 cm small. Okay, you just need to say, oh, this flower is 5 cm smaller. Unable to do task 5, flower A is 5 cm smaller. You don't have to say that, oh, the flower pot is made of green, yellow, blue. The flower stalk itself has this pattern, not relevant to the task that the agent needs to know. So if you already know what your agent is supposed to do, and you know that a lot of things that this function is calling, maybe it's doing video processing, maybe doing image processing, maybe the agent doesn't need to know that level of detail. The agent just needs to know, hey, yeah, this video, go and extract the subtitles for me. I don't need to know, oh, the video is of what format, the video of that, blah, 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 blah. We let the video extractor handle it, the video extractor function or agent handle it. All the agent needs to know is like video extraction complete or video extraction failed because of these reasons. Yeah, so if you don't need to store exactly everything that is done, okay, you don't have to put in subtask completed. Of course, right now, even without shared variables, you can also put a concise description of what has been done in subtask completed. You can already do that right now. Okay, so this is actually hand in hand. So what I mentioned over here, like this part here is actually done in subtask completed. So you just only give the bare minimum for the agent. So the idea is reduce context length. Okay, everything comes down to reduce context length. It works better if you have a smaller context length. So where does the bulk of the information come in? Like let's say you have processed your video or processed your image. You need somewhere to say, hey, the image is here, right? So you need something like a file path and so on. Oh, you can put the file path in this description. Or, if you have this thing called shared variables, you can actually put like a variable called like image files. Then you can put like the variable 1 for image 1, variable 2 for image 2. You can put that in the image files, the like process images and so on. Or you can put like the path names over here, like image path names. So you can put stuff like this in your shared variables, which means that the next time anyone wants to do image related stuff, they can just go to this shared variables and see what has been done so far. So it serves as a way to document what has been done. Like just now you saw the shop assistant, the items that we have searched, we put in shared variables. Okay, the items that the user has purchased, we put in shared variables also. Okay, so this means that if let's say we want a source of truth, okay, so source of truth, we can also use the shared variables as source of shared variables can be used as source of truth that will minimize hallucinations, because if you want the large language model to process like an image, it will only be based on whatever image that you store in your shared variables. Okay, the problem with subtask completed is that because it's like free text and so on, sometimes the LLM might hallucinate those free texts. Okay, so while yes, you want concise description, you can put here. Shared variables will store the actual like output, especially of different modalities. It will also be able to serve as a source of truth for the agent to do planning. Okay, so I have something here. Brian said, if only bosses don't care about this in real life, we wouldn't have Jira. Okay, this one, sorry, okay, okay, yeah. So basically, it's talking about like the flower pot or this, right? That was the example you're saying, like the boss don't need to care about all the details, right? Yeah. So all right. So this is shared variables in a nutshell. The main thing is that you can store extra things that you don't need the agent to know per se. You can put in shared variables. And also, if you want a source of truth for other functions to refer to, you can put in shared variables as well, so that all the functions know exactly. It's like a common state that the agents know. So subtask completed will also be known to all the functions and the agents, but this subtask completed is more free text. And this shared variables is more constrained. Like basically you already know what you want to keep track. Then you put in shared variables. Okay, so there are certain cases to use each of them, and I leave it to you to figure out what works best for your use case. But I provide both in the TaskGen framework because both are important. Okay, so how do we actually do shared variables? So there was a lot of talk on how to do what is shared variables, what are shared variables used for, but how do we actually do them? We have two ways to do it. One is by the large language model based function, which is basically given a function, you give a function description and you give an output format. So in order to access certain things from shared variable, I have made this a rule in TaskGen. If your function name starts with s underscore, okay, instead of getting this input variable from the planner, okay, because the planner is supposed to give like a function name and also like what are the input parameters for this function. It's the typical function calling stuff. So like over here, it will give the increment. So the LM will give increment. Okay, the variable increment. Okay, and shared variables will provide as total. So if you want to like add something to a sum, and your sum, you don't want the large language model to give you that sum, because large language models might hallucinate that input. They take from shared variables, because shared variables is something that you have defined in a rule-based manner to put in there. When you extract out from shared variables, it is a source of truth for you. So you can just put it in shared variables, and the output of your function can go into shared variables as well. So as long as your the output name is s something, it will be stored in shared variables. So this is for LLM based functions. If you just want to, like maybe take a number and add to a running total, you can do that as a shared variables in this add function. Okay, but my recommendation, okay, because when you do this kind of method for shared variables, you are leaving something to the large language model to output here. Like the large language model can hallucinate this output as well. Okay, so my recommendation is that if you have very fixed base stuff like this, add. I mean, add is something that large language models don't do very well anyway. Do an external function for it. So how do we do this for external functions? So normally external functions, you only have like the input variables here. So for example, here we want to create like a certain number of quotes about certain categories. Okay, you can have the number of quotes and the categories as your input. And all you need to do is just call shared variables in your function name itself. Backend TaskGen would give you the shared variables dictionary. And you can just take whatever you need from the dictionary. Okay, do whatever function you need here. You add in whatever processing thing you need here, and you just store it back into shared variables like that. So very easy. Put the shared variables in your input variable for your external function. Retrieve your shared variables and store it back to shared variables. So that's what we, Brian and I, in our sharings just now, actually we use shared variables quite extensively for a lot of things. Like in order to take things from the database, maybe for me, take things that the user has already selected. It all comes from shared variables. So in comes shared variables and out comes shared variables. Any questions for this shared variables part? Because I think this is key for production level stuff for TaskGen. You will have to use shared variables. Okay, you don't want the large language model to hallucinate your important variables. You want to keep those important variables fixed and preferably handle them in a rule-based manner. Rule-based means deterministic. Maybe you add numbers by using the addition operator in Python rather than using the large language model. All good? All right. Okay, so now we go to memory. All right, so memory is the bread and butter of my research, actually. I believe we'll reach artificial general intelligence, or at least something that can do generic tasks within the capability of the agent. We will reach it with memory. At least 50% or more will be reached with memory. And why do I say so? It's because humans, actually, we learn quite fast. We learn fast by mimicking others. We learn fast by learning from other people's experiences. We don't really need like 1,000 or million iterations or examples before we learn how to park a car, maybe, or to walk. We actually can do some mimic of like how people move their hands. We can mimic like what are the, so for example, if you want to study for an exam, you can mimic the model answer, We learn that pretty fast. And a large part of it is not done through, so there are two kinds of learning. One is like you keep repeating the action and you muscle memory, right? Like those, actually that's also memory, but that's a lower level. The memory over here actually comes in different forms, but it's a little higher than the motor actions. It's more of memory of like, or what context do you do this? What context do you do that? Like right now I drink my cup here, the actions of drinking my cup. Okay, in a different context, if I can retrieve that same action of drinking my cup, I can do that in another situation. And that's something that, reinforcement learning, a lot of different ways of learning, they do quite badly because they try to take in everything as one context. But if you can just split your context into like top level, bottom level, you can modularize the bottom level parts. You can mix and match, and you will learn much faster than if you treat the entire input stimuli as one state, which is what is done in current machine learning. Right? This is not the way to go. We need to decompose our input stimuli into many different abstraction spaces and handle them differently. And that's where memory comes in. Memory helps to augment each of these abstraction spaces with relevant information you have learned from in the past. Okay, so what's the problem we face right now? Okay, the problem we face right now is that, you want the agent to be adaptive, you want the agent to learn, okay, but, the real world, there's so many things you can learn. There's so many information that we can get from experience, expert knowledge. If you were to put everything you learn, okay, like okay, let me give you an example. If I were to let you put everything that you have learned in your entire life in your brain, and you basically, need to process through everything before you make a decision, do you think you will survive? If you need to process every single second of your life from when you were born until now, just to make a decision, who here thinks that that's possible, to process every single thing before you do an action, like maybe you want to walk, you want to eat? you consider everything you've done in the past. Anyone here thinks that's possible? Basically, you don't constrain what the agent used to process. You just process everything the agent has experienced.
That's impossible.
Yeah, maybe that's likely impossible now. I mean, in the future, if compute goes to that level, maybe it's possible. But I would say that right now, we need this kind of memory because we don't want to take every single action. We don't want to reference every single action. We want to store a lot of things in memory because you can use it for generic problem solving later on. But you only want to retrieve what the task needs you to retrieve. You don't want to retrieve more than that. Because, and large language models also, I realize the more functions you give it or the more memory you give it that's irrelevant, the more it hallucinates to do something that is irrelevant as well. The saying goes, garbage in, garbage out. If your prompt to the language model is garbage, the output you also expect garbage. So memory, if you can restrict what you give the prompt to only those that are relevant to the task, it will improve performance a lot. This is what I realized from the extraction and reasoning corpus when I did the multiple abstraction spaces and I gave it all the functions, even those that the abstraction space cannot handle. Like, for example, the pixel level space, I give it rotate grid. Sometimes it rotates the grid and it doesn't know what it's doing. So if you only give it the right functions based on the tasks, you only prompt the language model based on the tasks. It works way better than giving a generic prompt for everything. So let me emphasize that again. A task-specific prompts is way better than generic prompts. Okay, and this is something that TaskGen allows you to modify natively using the memory bank feature. Okay, we allow you to put in snippets of what your prompts might be. And based on the tasks, we'll do some retrieval augmented generation. We'll do some retrieval based on cosine similarity or a method of your choice. Or you can even just put this in your, if you are using like vector databases, you can also use the vector database as a way of retrieval. You can, in the memory class, we allow you to interface with the vector database as well. So this allows you to get better performance and refer across a larger instance of things, but only using very little words or tokens in your prompt. Okay, this is very crucial. Okay, mastering how to use memory is mastering how to do a performance system. So even in Symbian, when we implemented TaskGen in our use cases, the memory served a very key feature of how to expand what is possible with the system. So like the system only allows this thing. If you prompt it with more memory, you can actually map it to existing things. And for more diverse user queries, it can handle them if you put those diverse user queries in memory. So memory is a very useful way to learn from what the user types in. It's a very useful way to map very diverse inputs into a common fixed constraint output space. So let me give you an example of how the memory is done for functions. Okay, just for functions alone, let's say we have an agent and we have a few functions that we are giving it. So over here, few means like 15, okay? So I expect that agents can be given like 100 functions and so on. So what we can do is that we can actually define which functions are compulsory. So in TaskGen 1.2.0, I have a is compulsory variable here that you can just put is true. So when you define your function itself, you can define your your description, does takes num1 basically takes num1 ints and num2 ints and adds them. Then you can put like output format equals to sum, and then you can put like integer. So in your function definition, okay, you can take your function description and you can take your like function output format like that, and you can just add an is compulsory variable at the back. And this means that whenever we do the retrieval augmented generation for your task to choose only functions relevant to your task, it will always be chosen. Okay, so what kind of functions do you put here? Functions like rec functions, retrieval functions, basically additional context functions. Like you want those things to be called regardless of the task. Like you want to augment with different things, you can put them as a compulsory thing. Then we won't filter those functions away. They'll always be there when you do any task. All right, so those are core functions that you want. So now you can try this out. I put this new thing in 1.2.0 because I realized that if we just do task-based filtering for all functions generically, sometimes we miss out these important functions and the task fails. So if you already know this function is going to be useful, make it compulsory. All right. So that's one thing. And how does this work? So given a task, okay, we currently map by function name and description. We map it to the task, okay, using concise similarity. How this is compared and like filtered, you can change it in the memory class, okay? I'm not going to go through in detail how to do this. Refer to tutorial for memory for examples. So you can actually do this to do the matching and then get the relevant functions that you need. And these functions will go into the context of your agent for decision making. So can you see that that's this level of filtering here that is done in order to reduce the amount of information that the agent needs to know. And this actually helps improve performance if you get the right functions. All right, so there's a big if over here. A concise similarity may not cut it for your use case, so you might configure, you may have to do other methods of similarity. Like for example, keyword search. So this one I leave it to you for your use case, but the idea is based on your task at hand, you can compare to what you want to compare with, what attributes you want to compare with in your memory. Like you might also want to compare with input variables type, if you wanted to filter by type. Yeah, so I leave it to you how you want to do it. But the idea is if you filter those functions and you put them to the agent in the reduced function space, you get better performance if you reduce them correctly. All right. So this is one key thing about memory bank. There's a second thing about memory bank. Okay, but before I go into the second thing of memory bank, I'll just show you how this is done for a function. So like, for example, I want this is my calculate function, right? This is the agent's calculate method. And let's say I want to do this in order to, calculate something. So I have a list of functions. So this is in tutorial 4. In memory, you can also take a look at how this is done. I have a lot of functions here. So what I do right now is I basically, based on this input task, I create like add numbers, multiply numbers, divide numbers, power off. Actually, it's not too bad. I mean, like, I just merely give it this equation and GPT is able to infer like it's related to this. And this is just ChatGPT. So you can see that if we filter the list of functions to something that is relevant, essentially one thing is reduce context length for agent and then reduce hallucinations of calling wrong functions. So if we could do this pre-filtering step before we do the LLM-based decision, it works wonders. It works wonders. Okay, you can trust me on that. It works wonders. So if my app challenge I update with this, I will solve even more of the app challenge. Which, by the way, the paper just got accepted yesterday at the IEEE conference on artificial intelligence. Yeah. So TaskGen builds on the LLMs as a system of expert agents paper. It's way better than that paper. So this TaskGen is really like my key insights of 4 years of learning in PhD and so on, all in one. So what you are seeing here is a result of many years of thought. All right, so this is function-based filtering. This is the highlight. Okay, this is another highlight. So, just a standard prompt would be just this normal prompt that works for everything. But in most contexts, you don't want that to happen. You want to have extra things based on your task-specific memory. So it's like, for example, if you want to browse the web, so you can have the web instructions over here. You want to, do stuff like get stuff from AWS database. You can put over here. Of course, this is one way to do it. If you are doing by functions, my advice is create more agents or functions to do it. Okay, but one thing that you can do with this is that, maybe I use a different color, is that you can do something like intent to function mapping. So you can guide the LM how to use functions. Because, if you just do by description of the function itself, sometimes it may not match exactly the way you want it. So if you can map like how the user types in the intent and you map it to what functions you want to use, it will improve performance a lot. So this is why I call intent to function mapping. So this is one way to do it. Another way is, another stuff you can do is like you can put in different stuff like function-based prompts here. You can even, if you want to, you can even put in like document snippets. Oops. Document snippets here, and choose the right documents to show in this task-specific memory. Okay, although my recommendation is use a rec pipeline or function directly. So we try not to do like all the rec stuff in memory as much as possible that involves like the documents. Try to do it in a separate pipeline. It works better. But this task-specific memory is very good to augment the snippets of like what you want the agent to do, and you can put that in the task-specific memory. So let me show you an example. So again, first example here is like if let's say you want to do like very, very weird stuff, like you have this weird nonsense things, and then later you want to do this like my agent.run evaluate Azo plus Bonetti. Yeah. So this will give you a nonsense result, but if you have stuff that you can take, the LLM would actually be able to take in this Azo and Bonetti, and then it tells you that the answer is 3 because 1 + 2 = 3. It's able to do that if you give it memory like that. Again, this is just showing how the memory can be used. My recommendation is still, if you already know that you're going to be handling this kind of weird variables, you can do a rule-based pipeline check. Okay, so this is my recommendation. Is not to use this. My recommendation is user input. You run through rule-based checks to augment info, and then you just run the agent. So it could be done as a pipeline like that. It might work better. All right. Or you could, in the agent itself, you can also put a rec function and ask a planner to call it before any decision, before any further action. So TaskGen allows you to tell the agent to do that. But I do realize that sometimes the planner might fail. So if you already have a pipeline that definitely needs rec, my recommendation is to do this. Like you omit any source of failure. You just put this in a predefined pipeline, and the agent will then be used to decide what to do next for free flow mapping. Okay, so as rigid as possible, if you already know the fixed steps, is my recommendation. But if you don't know the fixed steps, feel free to put this stuff in memory, then we can at runtime evaluate what is needed. The more interesting thing is that you can even do stuff like this, sample task to function or intent to function. You can say, oh, I want you to find out about Azo and Ari, and then this is the function to use to convert the words. If I have a function booyah, then I can generate a code about TaskGen. So this is nothing to do with generating codes about TaskGen, but let's suppose you want to map booyah to TaskGen. So later on when you say like, for example, you say my agent.run gave me a booyah. So this actually will, I tested it, this will actually map to, this will map to code about TaskGen. So it's very flexible. It allows you to map a lot of different things together into one example by using this task to function mappings. Questions about this before I move on to the last one on additional context? Okay, so I will need about 15 minutes. So if you don't mind, I'll extend a little bit by 15 minutes just to finish this. So I go to additional context right now. So what is additional context? So if you look here, additional context is basically if you have a list of variables that are important, okay, like for example, agent state, like ingredients remaining, like I showed, I think Kyrian asked me before, like how to do ingredients remaining. You can put those in additional context. Money remaining, position in maze, what websites have you clicked, what items have you purchased. So stuff like this, will be relevant to the agent at any point of time. So what we can do is we can put this in the additional context prompt. So the rest of the prompt will be the normal prompt, like that includes the memory and so on. But you can also put additional context prompt here to store all this. This, I would say, are like the high level goals that the agent has, that regardless of point of life or point whatever the agent is doing, you need to remember these variables. Like, I mean, in humans, I would say that this would be food, water, toilet. I mean, like body state, and so on. So all these are high-level things that apply for any context or any task, put in additional context. All right. So even if you are doing a chatbot, your conversation, okay, which is important, can also be stored in additional context. So the key question is, people will ask me, is like, what is the difference between additional context and shared variables? Anyone want to guess if I share the difference? Okay, so let me just share it. All right. Additional context goes into agent prompt at all times. So, you know, if you want to program additional instructions to the agent that applies for all use cases, you can do it in additional context. Okay, if you are only doing for some use cases, use the memory. Okay, use what I showed you in the previous slide. Use this one. If it's only for specific context, use this one. But if you are using for any context, okay, we put in additional context. Actually, maybe I should call this global context, you know, because it kind of feels like global context rather than additional context. So I don't know, maybe I'll rename this to be global context, because additional context does feel like, you know, it can be omitted, right? Yeah. So maybe global context might be a better way to say this. Okay. So maybe I'll just rename this to global context. All right. So what example of additional context right now is like you can output additional information to the agent based on what is important. Like for the chatbot, the money remaining, items purchase, item search, past conversation, all this can be output to the agent. And guess what? We use shared variables as part of the prompt. Any guesses why shared variables are used here? Anyone want to make a guess? Like why in additional context we reference the shared variables for the prompt? Yeah, anyone reply or?
Because you can share the shared variables to many other agents, then like it's easier to like pass the additional context around.
Yeah. That's one reason, is basically the functions can update the shared variables and you can use it to condition the agent's global context. The other reasons is the other thing is shared variables are a source of truth. Okay, if we don't really put shared variables here, then what needs to be done is the LLM needs to generate it themselves, and you know that can be a source of failure. So yeah, we would be able to put this inside the additional context or global context. So Kyron just said global context is better, right? Okay, it'll be global context in the next version of TaskGen. Right. So this global context here, you can store in whatever the agent needs. And you know what's the benefit of additional context or global context is that we can actually reset the subtask completed every task. Because, you know, if we keep all the past subtasks that has been done, like, oh, move up, move up, move up, move left, or I click on this webpage A, webpage B, webpage C. Sometimes if you ask it, oh, click on webpage D, the agent might actually think he has done the task because webpage D might be the same name as webpage A. And then the agent's like, hey, I clicked on webpage A already, you know, if you ask me to click on webpage G, isn't it? I'm done. So they will just do nothing. All right. So if you just reset your subtask completed every task and put what important information is like, oh, what websites have I browsed, like the history and stuff, you can put them in a very concise form in additional context. It actually makes the agent perform better. Okay, so take note. I think real world use cases try to use additional context or global context. It works way better. Okay, at least based on my experimentations. So last week or 3 weeks ago, I think someone asked about whether you can save and load agents. So back then, 3 weeks ago, don't have, but I've created a function for you, so you can pickle this to myagent.pickle, and you can just load again like that from the pickle. So you can load the agent with all the states and everything. Backend, we use pickle. Actually, not really pickle. We use this thing called deal, right? Which actually does why deal. Deal allows for lambda functions, for pickling lambda functions and other messy data types. You know that the typical pickle doesn't store. So backend we use deal to like save in the pickle file and then load from the pickle file. So you can save your entire agent to another page if you want to, with all the memory and everything. So yeah, that's one thing, a new feature that I like to just introduce. And yeah, we have reached the last part of the presentation. So I just do a brief recap of what we have covered so far. We have talked about shared variables today, a way for the functions and the agents to interact with one another without putting anything in the agent's context, because shared variables is totally external and transparent to the agent. And we talk about memory and how you can use memory to do the function filtering, to filter only those important functions for the task. Memory can also be used to augment the prompt of the agent with relevant task-specific examples, like intent to function mapping, or you can even provide additional context to like the web browsing agent and so on based on the task at hand. All right, then finally, we talked about the last part, which is on additional context or global context, which we can actually use to put in things that the agent might need to use globally for regardless of any task. So I see something in the chat. Karen, you said in real world situations, we might have conflicting global context over time and between agent. Do you want to explain that? Because I don't quite get that. Karen, can't hear you. Are you talking now?
Yes. So what I mean is that if the agent were to complete several tasks, and then each of those tasks will have a specific global context, and over time, if we do not clear the context or clear the memory, we might have conflicts, right? Because users can inject different global contexts, or between agents, they can follow different global contexts, right?
Okay, so the beauty of this global context or additional context is that because you can define anything you want here, but my recommendation is use shared variables. Because you use shared variables, the user cannot control the shared variables directly. It's done at the back end by your own rules in the functions to do this. So what this means is that an injection attack by the user is very unlikely in this shared variables. Unless, of course, you expose the shared variables directly to the user in one of the function calls. But, if you do good design, this context would be a global one, and it will not be able to be modified by the user. You can think of this like shared variables as like your own internal database that the user doesn't have control over. So I would say that the chance of what you are describing is of happening is quite rare. I mean, that will happen if you expose directly the shared variables to the user, which you probably shouldn't. Yeah, but if you take safeguards for this, these shared variables are totally internal to you, and you have full control over it.
Oh, I see. Okay. Yeah. Got you.
So again, I think in order to use TaskGen properly, we will need some examples. So I'm going to create more examples on how to use it, and as I do more and more use cases, we'll discover some of the flaws that the current architecture has. We will change it. It'll be very, very good at the end of it. So I encourage all of y'all to try to use it for your use case. If you see something that is an issue, let me know. We can see whether we can change TaskGen itself, or we can just change the structure of how the workflow is structured for you. So the key guideline I have is that if something is fixed and rigid, and you always need to do that step, don't use TaskGen to do it. Do it in one of the functions. Basically, don't use the planner to do it for something that you already know you need to do it. So like 100%, you definitely need to retrieve from this document. Just do it as a fixed step. And that will be one part of the pipeline. Then the second part that you call TaskGen. Because you should only call TaskGen. Okay, let me just put here. Only use TaskGen for flexible input to function mapping. Okay, if your use case doesn't need flexible input to function mapping, it's a very rigid pipeline. Okay, rigid pipelines should come before or after TaskGen, or put inside one of the equipped functions. Okay, so just take note, TaskGen is not a way to do a rigid and consistent workflow all the time. The main use of TaskGen is to flexibly match the user intent to a set of predefined functions. Okay, and so use it for the right purpose. So just to emphasize this point here. So rigid pipelines, please do a rule-based function yourself, because I think that's the best way to do it. Okay, so the first question I have is that how do we store memory in multiple abstraction spaces, and how do we choose the right abstraction spaces to use? So just to quickly answer this question, I would say that like each agent has a different abstraction space, and then you should the memory should be targeted to agents specific abstraction space. So for example, if you talk about Arc Challenge, one agent would look at pixels, one agent look at objects, one agent look at the entire scene. When you prompt the agent with the memory, basically like the task-based memory prompt, don't put to the object agent memory of the pixel agent, okay? Because that will confuse the agent. You should only prompt the memory specific to the agent itself. Okay, so I would say that each agent having one abstraction space is actually the best way to go about it, because it avoids any confusion. And overall as a system, all agents will use separate abstraction spaces in parallel or in a layered manner. So in some sense, this helps to break the problem into simpler parts, or like solve the problem in parallel tracks. And this helps the robustness of the system. But within that specific agent itself, try to just use only one abstraction space, because that works better. Okay, anything to add for this? Because I do think this memory is a key thing. If you want to get very general agents, we kind of need to form memory in the right abstraction spaces. We need to also have multiple agents that can use multiple abstraction spaces. And, you know, I don't even think this abstraction space is best left to learn, all right? This abstraction space is best to be predefined to the task. Okay, because if you learn it, there's a chance that you might learn wrongly and so on. Comments on this? Okay, if not, I move on to the next one. Is there a better way to retrieve your memory other than cosine similarity? Because right now what we do is we have a task, and then we have a memory item, and then we just do cosine similarity of text. Okay, so the thing is there a better way to retrieve it? And I would say that yes, if your task is keyword based, you might use keyword search. For example, you have this BM25 or like TF IDF. This might work better for that kind of use cases. Term frequency, inverse document frequency. It might work. Just a simple keyword search will do. So depending on the task, you know, sometimes you might want to do that. Also, you know, if you have more advanced ways of mapping memory, like for example, context-dependent embeddings, you can refer to the YouTube video I talked about that before. You might implement something like that to map memory based on context, because I believe that memory is not just existing on its own. You actually need to infer the context of what you want to do with that memory, and then you can use it to match better. Like a context of, for example, bank. If your context is the river, right, you would think of river bank. But bank, if your context is financial, you think of the financial bank. So the way we map this to is very different, and it all depends on context. So right now, the cosine similarity, there's not much context inbuilt in this. If you can have a way to do context-dependent embeddings, like for example, map the set of words to another set of words based on context, I think that works way better. So again, all this can be done in the TaskGen framework. You can just change the memory class implementation. So in your memory class, you can change default cosine similarity. You can also do other stuff like implement vector search. So vector search is still cosine similarity in some sense, but you know, most use cases actually vector search is enough. You retrieve from a vector database like Pinecone. I think good enough for most use cases. Comments on this before I move on to the last question? Okay, the last question, how can the agent infer the task if it's not provided by the user directly? So earlier you saw in my chatbot example, like the user did not say like, okay, buy exactly this item. The user would just say, okay, buy me the car. You know, it's like you don't have a fixed input like car. You know, like sometimes in most use cases, you just constrain the user's input to just say car. But let's say if the task is not done properly, how can the agent infer this task? This is a difficult problem actually. What we can do is we could use memory to guide what styles of user query leads to the function. Okay. Also, we could do like zero shot or few shot prompting of this. Yeah. Also, if you want, you could also have a separate function to infer user intent from conversational history. So this again is a pipeline process. The thing is, if you just have separate functions for each pipeline, actually you can run better in terms of like it's more targeted. The cost is that there's more latency because each pipeline will use LLM, and then you might use more runtime in total. So again, it depends again on how reliable you want the system to be versus how fast you want the system to respond. So sometimes you want the system to respond fast, but you don't really care that, okay, a little inaccuracy is fine. Then maybe you can omit those kind of pipelines like this separate function. So this one again is design choice by business use cases. Leave it to each business to decide. My aim is not to make this totally like business kind of thing. The main thing is, depending on use case, it could be like you want to create a game, you want to do your like AWS retrieval, you want to just talk to your documents. All this can all be done with TaskGen. And how accurate you want it to be depends on how much time you have to wait. Right? You want to wait more, you can implement more and more functions in the pipeline. Okay, so actually that's all I have to talk about today for TaskGen. I hope it's clear, because I'm actually quite excited about this whole thing about chat. Let me just go here. Chat variables, memory, and additional context or global context, I think can help improve a lot of the performance of TaskGen. All right. Any final words before I conclude the session? All right. Thank you, and I'll see you all again next time. Okay.
Right.
Bye.
Thanks, John. Thanks for the session.
Okay, no worries.